Hello, my name is Andrew Baden, and my project was the comparison of electrolytes for the purpose of CO2 reduction. I came up with this idea because of the recent Paris Agreement that came up between the countries of the world, and some researchers from the University of California were able to separate carbon from carbon dioxide using low energy and low heat. That is a very good monumental task because of the chemical makeup of carbon dioxide and the way the oxygen molecules and the carbon molecules are bonded. So what the researchers did is they had a glass tube that had an electrolyte inside of it with some Galveston, some FTO glass, and a transformer running from them, making a current through the system. I wanted to replicate this, but with items you can find around the house or at a hardware store, as the researchers used lab-grade equipment and chemicals. So the first part of my project is I made the apparatus that they made, which was a big glass tube, but I had a nozzle on the top and a nozzle on the bottom. What I would do is I was going to put the electrolyte in from the top nozzle, and it would fill the container, and I would bubble in CO2 from the bottom, which would dissolve into the electrolyte. And then I would run a current using a graphite electrode, the Galveston, and a piece of FTO glass, all connected to a transformer, which would send a current through the system in hopes of getting some carbon flakes to form near the top of the Galveston. But to find this, I needed to find the best electrolyte that I could. So I found some readily accessible items, which were methanol, ethanol, water, and toluene. And for this, I extracted all the gas from them, and I poured them into Petri dishes about 2/3 of the way full. Then I had a large bucket of water, and in the bottom was a hole. There I would use dry ice, and I would bubble in CO2 through the bottom. Then I would take empty syringes with a valve on top so that no carbon dioxide could escape from the syringe. I would put it on top of the carbon dioxide, and I would wait until it's completely full of carbon dioxide. Then I would take it away and place a beaker on top so that it wouldn't float up and the carbon dioxide would leave because of the density is so much lighter than the water. When I was ready to put the syringes in the Petri dishes, I would take a glass plate, I would stick it under the syringe, and I would take it over to the Petri dishes. I would completely submerge them, then take the piece of glass away. This way, it prevented no carbon dioxide from escaping, or oxygen, or nitrogen, or some other gas from entering into the system. Then, I would wait about 10 minutes, and I would see how the levels differed between them. Methanol was a clear winner. It filled the entire syringe. Ethanol did not do very well, and toluene and water both did not dissolve any carbon dioxide. For my second trial, I used the same ethanol, but I used a different ethanol. I used a lab-grade ethanol, which was 95%, instead of a 85% solution of ethanol I got from the hardware store. I also, instead of toluene and water, I used isopropyl alcohol, which was another readily accessible solution that I thought could dissolve carbon dioxide well. And I ran it again. Methanol was still the winner, as it filled the syringe again. Ethanol did about 50% as good as methanol did, but it still wasn't the best. And isopropyl alcohol did not dissolve any carbon dioxide. I ran this test again to check my results, and they were confirmed. And so I needed to make the solution more conductive, because by itself the methanol was only getting about 200 millisiemens or microsiemens per centimeter, and that wasn't very good conductivity I should be getting. So I added benzalkonium chloride, which was a 50% solution. I added 12 milliliters to a 200 milliliter solution, and I ran it again. It did not change the methanol. Methanol still completely filled the syringe, dissolving all the carbon dioxide. The ethanol, it significantly decreased the amount the ethanol could dissolve, and isopropyl alcohol did not change much. So after finding out which was the most conductive and the best solution to use for my experiment, I wanted to try and run the actual test. So in the test, I created the glass tube, but instead of bubbling carbon dioxide through the bottom, I instead bubbled the carbon dioxide through the solution before I put it into the apparatus. So there I had my FTO glass with Galveston on top of it, and I also had a cerium added to create a Galveston cerium compound, and the cerium would act as my catalyst for this experiment. Then I took a copper wire, I attached it to the FTO glass, and I attached that to a positive to a transformer. And the graphite electrode near the top of the Galveston, I plugged that into a positive and plugged that into a transformer. And there I increased the voltage very slightly, about 0.1 volts per second, and nothing was happening, so I instead immediately cranked it up to 3 volts, in which tiny bubbles started just forming on top of the graphite electrode, and then I cranked it up a little higher to 4.7 volts. And at that time I was getting about 0.12 amps of current going through the system, which was good that I was getting current, but it wasn't the current I was as much current I was looking for. And so in the end, bubbles just formed on the graphite electrode, and a white stringy substance formed in between the Galveston and the graphite electrode, which I assume is the benzalkonium chloride being taken away from the methanol that I used in my solution. Some reasons why I think methanol dissolved carbon dioxide is the best is because of its chemical makeup. Methanol is 1 carbon, 3 hydrogens, and peroxide at the end, and it has just a very low atomic mass and structure, as opposed to ethanol, which has 2 carbon, 5 hydrogens, and with peroxide at the end, and isopropyl alcohol, which has 3 carbons, 8 hydrogens, and peroxide at the end. The reason also why carbon dioxide can be dissolved in these solutions is because of carbon dioxide's polar bonds. They attach to other solutions very easily. It just depends what the solutions are chemically made up of. In conclusion, I found that methanol was the best solution to use for dissolving carbon dioxide. Unfortunately, I was unable to obtain the carbon dioxide, but the thought that this is possible to do with home tools that you can find around the house is very good to know for future reference in case we need to fight the climate crisis and solve the carbon dioxide problem that we have. Thank you.